let's just jump right into it. When we think about the global tech economy today, semiconductors are, quite frankly, the undeniable center of gravity, right? But breaking into this industry, it's notoriously difficult, especially for developing tech nations. So in this explainer, we're unpacking a really fascinating roadmap, one that shows how Vietnam might just bypass that agonizingly slow, traditional route and take a massive strategic shortcut to the top. Now, the immediate assumption for any country wanting to join the chip supply chain is that they've got to spend billions, literally tens of billions of dollars on those massive manufacturing plants, the fabs. But we have to ask, is that really the smartest move for a developing tech nation? Entering the manufacturing game means going head-to-head with countries that have a decades-long head start and, let's face it, incredibly deep pockets. It is a high-stakes, ridiculously high-risk game.
But there's a workaround. We're exploring a brilliant strategy championed by Dr. David Nghiem. He suggests Vietnam should completely bypass those Goliath-sized costs and the huge operational risks of manufacturing, and instead focus entirely on high-value design. Because by capturing the core intellectual property, Vietnam can actually generate massive value without being crushed by the weight of building all that infrastructure.
So here's how we're going to break this down today. First, we'll look at the big semiconductor dream, then dive into why design is the ultimate shortcut. After that, we've got a tricky 6G physics problem to tackle, followed by how this all ties into mastering cybersecurity. Finally, we'll look at a really clever human resource solution and see how all of this builds a breakthrough ecosystem. Starting with that first piece, the global ambition. Semiconductors are absolutely the backbone of our modern world. We're talking everything from artificial intelligence to next-gen telecommunications, and Vietnam, they want a much deeper, more substantial role in this global value chain.
But to avoid a really costly war with countries that are literally decades ahead, Dr. David Nghiem proposes a totally different path. Now, Dr. Nghiem is a Vietnamese-American expert with decades of experience at tech giants. We're talking Qualcomm, Medtronic, the University of Houston, and he argues that instead of competing directly in chip manufacturing, Vietnam needs to pivot. They should focus on design, specifically integrated antenna technology, and training high-quality human resources. The key here isn't building the physical chip itself, but designing the incredibly complex communication systems that sit right on top of it. And that brings us to the shortcut. Think of design as a Trojan horse. You see, you actually don't need to own the factory to own the technology. By mastering the design phase, Vietnam can embed itself into the global supply chain as an absolutely indispensable partner, rather than just being another assembly line.
Dr. Nghiem argues that Vietnam's exact breakthrough point should be something called RFIC, or Radio Frequency Integrated Circuits. This is the highly complex technology of integrating radio antennas directly onto semiconductor chips. By mastering RFIC integrated antennas, Vietnam is the one creating the core technology that makes wireless communication possible, instead of just slapping together the physical parts that somebody else designed. When you look at the two strategies, the contrast is stark. By adopting a design-focused model, think of how Apple or Qualcomm operate, Vietnam can control the absolute most valuable part of the process. They own the core IP, and they do it with a much more moderate investment level. Meanwhile, they can just outsource the risky, capital-heavy physical production to specialized manufacturing partners. It's the classic definition of working smarter, not harder. Of course, making this shortcut work isn't just about good business sense. It means they have to overcome some seriously intense scientific hurdles, especially as the whole world is racing toward the 6G era. And the foundational hurdle here is what we can call the physics paradox. It's a brutal law of physics. Whenever you shrink an antenna enough to actually fit it onto a microscopic chip, you drastically reduce its power and its radiation efficiency. Smaller size usually means a much weaker signal. Defeating this paradox? That requires absolute mastery of design. To make this work, an engineer has to brilliantly control several critical factors. They have to match impedance to stop energy from being lost, maintain that radiation efficiency, and really carefully control the emission characteristics. But here is the absolute genius part. Instead of fighting the environment, an expert designer actually treats the chip and all its surrounding metal structures as one unified electromagnetic system. They use those surrounding metals to literally boost the signal. And the challenge gets even wilder from there. As we push into 6G's terahertz frequencies, the normal physical rules start to warp.
At these ultra-high frequencies, the semiconductor materials themselves actually absorb more energy. And even worse, regular transmission lines on the chip start acting like unwanted, accidental antennas, which causes massive interference. Solving this takes a level of elite, highly specialized knowledge that Vietnam is actively aiming to cultivate. Now, solving this physics puzzle isn't just about getting faster smartphones or better download speeds. It is fundamentally about national sovereignty and mastering cybersecurity.
Think of the antenna as the front door to a house. It's the very first point of contact for any wireless signal entering a device. And, well, if you're the one who builds that door, you get to control the locks. You can control signal filtering and block interference right at the point of entry, long before that data even reaches the software layer.
As Dr. Nghiem points out, mastering this technology isn't just about technical performance. It relates directly to technology security, cybersecurity, and national autonomy. By owning the antenna design, Vietnam wouldn't just be assembling tech parts. They'd actually have the power to protect their systems from the ground up, right at the hardware layer. That grants a level of technological security that you simply cannot buy off the shelf. So, the strategy is brilliant, the science is complex but definitely solvable, and the security benefits are massive. But what's the bottleneck? What is stopping this from happening tomorrow? Well, it all comes down to people. 6. That is the number of months it takes to create a breakthrough here. Through his Talented Minds Agency, which mentors young tech talent, Dr. Nghiem believes that with a highly practical, industry-focused curriculum, a Vietnamese student with a solid foundation in math and electronics can be trained as a highly capable antenna design engineer in just 6 months. Not years, guys, just 6 months. Now you might be wondering, how do they practice without access to billion-dollar facilities? Well, Dr. Nghiem has actually developed these revolutionary, low-cost measurement methods. They allow universities to test antenna efficiency without having to build wildly expensive, multi-million-dollar measurement chambers. This completely removes the massive financial barrier that usually stops developing nations from doing high-level hardware research. And that brings us to the breakthrough ecosystem, the grand conclusion. How do we actually pull all these pieces, the strategy, the physics, the security, and the talent, into one cohesive national master plan? The roadmap is surprisingly clear. Step 1, you implement that practical 6-month education program. Step 2, establish a local antenna design center to actually house this new talent. Step 3, the government steps in to support this with favorable tax policies and equipment import assistance. And finally, Step 4, use this solid foundation to expand into full semiconductor integration. Building this ecosystem creates massive outcomes. This design center wouldn't just be some academic classroom. It would generate real, independent commercial products and bring in initial revenue. It builds up a high-level engineering workforce. But most importantly, by having their own core intellectual property, it elevates Vietnam. They go from being a mere tech recipient to being an equal partner with giants like Qualcomm. Because let's be real, you have to bring something to the table if you want to see that. So this strategic shortcut is right there for the taking. Dr. Nghem's blueprint proves that with the right focus on design and talent, these massive barriers to entry can absolutely be shattered. Which leaves us with one crucial, really provocative question about Vietnam's technological destiny. Will Vietnam remain content to just assemble the future, or will they step up and design it? Thanks so much for joining me on this explainer today. Keep learning, and I'll catch you next time.